3.2 watts with a Bluetooth controller talking. Start driving with lights on. 12 watts. Driving with lights off. Full speed, 7.5 watts. And driving. Oof. Let's try driving in real life. So this is the battery that we normally use. I happen to have a similar one from LG on the robot right now, but most people using Scuttles just have this one. And I compiled the basic information from our driving with Bluetooth, but idle. We're at 3.2 watts. This is watts. Driving with the wheels off the ground, 7.5. When we went onto the ground, it was still 7.5, but I think the velocity is just a little slower. And this is when I was driving in reverse because the lights are off during that time. And the lights are not a normal feature, I just added those on, so I measured those also. Driving on the ground with the accessory lights on, 12.5 watts. And this is all using the Raspberry Pi. I've measured in the past with the Beaglebone, and it's a similar power level, something below 7.5 while driving. So very power efficient. This is just a graph of the same information, and then here's some more analysis. I have a chart from 2006 that I made when I tested one individual Panasonic cell, and I reran this several times with different conditions, but basically I discharged it at a constant rate of 1 amp, and this is not relevant information. This is relevant, and this is relevant. The starting voltage is actually up here. It says started at 4.13 volts, ending at 2.8. That actually was the cutoff for the test, and the total tested capacity was 3.02 amps. And this just shows this is description, so that's not physically controlling the test. Discharge rate 1 amp. That's actually controlling the test. And you can see it looks like this. So if you want to stay very conservative, actually you stop it earlier than 2.8 volts, because that's when you get this drop off, and there's no need to go near there if you don't need to, if you don't have to. Okay, so now let's open up Excel again. Voltage 1 is 4.1, voltage 2 is 2.8, and the average is 3.4. So the area under the curve would be the amp hours times the average voltage. That gives us the watt hours capacity. Okay, so 10.5, and that agrees with an article I just read about modern 18650 cells. Even though this test was back in 2016. Yeah, crazy. And we have 3 cells in our pack, so the capacity of the pack is 31 watt hours. And if we're using the regular driving, it's 7.5 watts consumed across 31 watt hours, gives us 4.2 hours. If this was, if you're actually idling and you're just mostly testing, doing software and other things, then this would actually be 3.2. And you can run for 10 hours. And once again, that's the if you want to be conservative, you want to turn off your machine early and start to recharge it. But that's really nice. It gives some flexibility.